Good morning. In the last class, we were discussing about basic nature of amines in aqueous medium as well as in gaseous medium or gaseous phase and aqueous phase. Today, we are going to discuss some of the chemical properties or chemical reactions of amines. We are going to discuss chemical properties of amines in that first chemical reaction, that is acylation. First chemical reaction, it is what? It is acylation. Now, what is acylation? What is the definition of acylation? Acylation means replacement of hydrogen atom, replacement of hydrogen atom by an acyl group, replacement of an hydrogen atom, it is replaced by acyl group. Hydrogen replaced by acyl group. Formula of acyl group, it is R C double bond O. It is what? It is R C double bond O. So, replacement of hydrogen atom by an acyl group, that is R C double bond O. This reaction, it is called as acylation. What is alkylation? Alkylation means what? Replacing hydrogen by alkyl group. Hydrogen by alkyl group. H, if it is replaced by R, we call it as alkylation. Here H, it is replaced by R C double bond O, that is acyl group. So, reaction, it is named as what? Acylation. See, for acylation we need a reagent, that is either acid chloride. Acylation can be carried out by adding acid chloride. Acid chloride formula, it is R C double bond O Cl. Acylation, it is carried out by adding acid chloride or by adding acid anhydride. Either we can use acid chloride or we can use acid anhydride. Why it is named as acid chloride, acid anhydride? Because acid chlorides and acid anhydrides, these are the compounds derived from carboxylic acids. Carboxylic acid. Here you can see carboxylic acid formula, it is what? It is R C double bond O OH. C double bond O OH. Here OH, it is replaced by Cl. OH, it is replaced by Cl. We call it as acid chloride. Second compound. What is that second compound? It is acid anhydride. Acid anhydride. Anhydride means without water molecule. So, we need 2 molecules of acid, 2 molecules of acid heated in the presence of dehydrating agents, either phosphorus pentoxide or we can use sulfuric acid also. So, phosphorus pentoxide, dehydrating agent, its role to remove water. So, P2O5, it is a very good dehydrating agent, it readily removes water, thereby we will get what? We will get R C double bond O, this one, then it is O, again C double bond O, then it is R. This is called as what? It is called as acid anhydride. This compound can also be written as RCO. This is also RCO. So, it is RCO 2 times O bonded to oxygen. So, this is acid anhydride. Formula of acid anhydride, it is R C double bond O C double bond O R, or it is R C double bond O twice O, and this compound, it is obtained from carboxylic acid. When 2 molecules of carboxylic acid, when they are heated in the presence of dehydrating agent, removal of water takes place, forming what? Forming acid anhydride. So, formula of acid anhydride, it is R C double bond O C double bond O, it is R. So, acylation means replacing hydrogen by acyl group. For acylation, we need either acid chloride or acid anhydride. Formula of acid chloride, it is R C double bond O Cl. Formula of acid anhydride, it is R C double bond O C double bond O R. Now let us explain the reaction, acylation of amines. See, acylation means replacing hydrogen by acyl group. Acylation, it is answered only by primary and secondary amines. Acylation reaction, it is seen only in the case of primary and secondary amine, that is aliphatic as well as aromatic. So, aliphatic and aromatic primary and secondary amines undergo acylation in the presence of either acid chloride or acid anhydride. Formed product will be, that product it is named as N substituted amide. When a primary amine or secondary amine undergoes acylation, product obtained, it is called as what? N substituted. So, upon nitrogen there is the substituent group N substituted amide. We know the formula of amide. Formula of amide, it is R C double bond O NH2, R C double bond O NH2. Now, why tertiary amine cannot undergo acylation? Why it is not seen in the case of tertiary amine? Acylation, it is not seen in the case of tertiary amine, because for acylation we need hydrogen. Hydrogen must be replaced by acyl group. In the case of primary, functional group of primary amine, it is NH2. There are 2 hydrogen atoms, so we can replace hydrogen. Functional group of secondary amine, it is NH. So, again there is a hydrogen atom, we can replace that hydrogen. What about tertiary? Functional group of tertiary amine, it is only N. It is what N? There is no hydrogen. Since there is no hydrogen in the case of tertiary amine, it cannot undergo acylation. Let us take up examples, primary amine as well as secondary reactions of primary amines and secondary amines. I will take primary amine. Ethylamine. Ethylamine, it is made to react with acid chloride. I can write it like this. Acid chloride, formula of acid chloride, it is R C double bond O Cl. In the place of R, I wrote CH3. In the place of R, there is what? There is methyl group CH3. Name of this compound, this is acetyl chloride. What is this? Acetyl chloride. And this reaction, it is what? It is a nucleophilic substitution reaction. Nucleophilic substitution reaction. I will write it here. See, NH2 can be written as NHH. NHH. So, during the reaction, HCl will be removed. HCl will be removed. So, product formed will be C2H5 NH, C2H5 NH. On the right hand side, we have C double bond O CH3, C double bond O CH3, plus it is what? Plus HCl. Plus what? Plus HCl. HCl means hydrochloric acid. So, in order to neutralize this acid, we are adding a base. We can add pyridine. Pyridine, it is a base. So, to neutralize hydrochloric acid, a base is added. Reaction, it is carried out in the presence of a base. Let us name this compound, formed product. See, this is N, nitrogen. Upon nitrogen, there is what? There is a substituent group. There is what? There is a substituent group. Name of this substituent group, it is ethyl group. So, I can name it as, it is N-ethyl. It is what? It is N-ethyl. Okay. Now, how many carbon atoms we can see here? there are totally 2 carbon atoms, so it is ethane. Then I have to add the suffix, that is amide, ethanamide. It is N-ethyl, ethanamide, N-ethyl, ethanamide. This is the product form. That is when ethylamine, primary amine, when it reacts with acetyl chloride in the presence of a base, will get out N-ethyl ethanamide, N-ethyl ethanamide. We can take secondary amines also. C2H5 NH C2H5. What is this? This is secondary amine, diethylamine. Diethylamine. When it reacts with acid chloride, formula of acid chloride, it is Cl, C double bond O, CH3. This is acetyl chloride. Removal of HCl takes place. Removal of HCl takes place. Reaction, it is carried out in the presence of a base. Let us write the product. C2H5, then it is N. Again below C2H5. On the other side, it is C double bond O, CH3 plus HCl, plus HCl. See, these are these two, they are substituent groups present upon nitrogen. So it is named as N, named as what? N, diethyl. N, diethyl. Again, there are 2 carbon atoms, ethanamide. N, diethyl ethanamide. So this is about the reaction of primary aliphatic primary amine and aliphatic secondary amine with acid chloride. We can take aromatic amines also. Let us take aniline. Formula of aniline, it is benzene ring, C6H5 NH2. NH2 can be written like this because we have to remove hydrogen during acylation. So one hydrogen, I will write it separately. This is aniline, or it is also called as benzenamine. Also called as what? Benzenamine, and this is aromatic primary amine. Aromatic primary amine. See, when it is made to react with, I will take acid anhydride. Formula of acid anhydride, it is R, C double bond O, O, C double bond O, R. In the place of R, we can write CH3. So this is CH3, C double bond O, again O, C double bond O, CH3. So this is an example for anhydride, acid anhydride, and this acid anhydride, it is obtained by heating 2 molecules of acetic acid. 2 molecules of acetic acid. Formula of acetic acid, CH3COOH. CH3COOH. So 2 molecules of acetic acid, when it is heated, 2 molecules of acetic acid, when they are heated, removal of water takes place, thereby we will get anhydride. That anhydride, it is called acetic anhydride. This anhydride, it is named as what? Acetic anhydride. Why it is named as acetic anhydride? Because this anhydride, it is derived from acetic acid. Derived from what? Derived from acetic acid. So reaction, it is carried out in the presence of a base. During the reaction, a molecule of an acid, which acid? This is CH3, C double bond O, C double bond O OH, C double bond O OH. Product form, it is C6H5 NH, C6H5 NH, this side C double bond O CH3, C double bond O CH. Now this is the substituent group present upon nitrogen. This is named as what? It is N-phenyl. What is this? N-phenyl ethanamide. N-phenyl ethanamide, or it is also called as acetanilide, also named as what? Acetanilide, N-phenyl ethanamide, or it is acetanilide. So this is the product obtained when aniline reacts with acetic anhydride, or acid chloride, acetyl chloride. We will get this product N-phenyl ethanamide. Next one, second reaction. This is very important. Carbylamine reaction. Carbylamine reaction, also called as what? Isocyanide test. Isocyanide test. Now what is this carbylamine? Carbylamine means isocyanide. Carbylamine means what? Isocyanide. So isocyanides, they are called as carbylamines. Isocyanides, they are called as what? Carbylamine. Now how to produce an isocyanide, or how to produce a carbylamine? See, carbylamine means isocyanide. It is obtained by heating. Isocyanides are formed by heating primary amine, either aliphatic or aromatic primary amine, with chloroform and alcoholic, that is ethanolic KOH, potassium hydroxide. So when a primary amine, aliphatic or aromatic primary amine, when it is heated with chloroform and alcoholic potassium hydroxide, isocyanides are formed. Isocyanides are formed, or carbylamine is formed, which is having foul smell. Having what? Having foul smell or intolerable smell. Isocyanides, they are having foul smell or intolerable smell. So isocyanide having intolerable smell, it is obtained. Reaction, it is called as what? Reaction, it is called as carbylamine. So carbylamine means isocyanide. How it is obtained? Isocyanide, it is obtained by heating aliphatic or aromatic primary amine with chloroform and alcoholic potassium hydroxide. When we heat this mixture, we will get what? We will get isocyanides having intolerable smell or foul smell. This reaction, it is called as what? This reaction, it is called as carbylamine reaction. Reaction, it is named as what? Carbylamine reaction. Remember, carbylamine reaction, it is answered only by primary amine. It is answered only by primary amine. This reaction, it is not seen in the case of secondary and tertiary amine. Secondary and tertiary amine. So secondary and tertiary amines does not answer carbylamine test or isocyanide test. So since it is answered only by primary amine, since this reaction, it is seen only in the case of primary amine, this test or this reaction can be used to distinguish primary amine from secondary and tertiary. It can be used to identify primary amine from what? From secondary and tertiary amines. So let us write the equation for this. We need primary amine. Formula of primary amine, it is NH2. This is primary amine heated with what? Chloroform. Formula of chloroform, it is CHCl3. I'll write it like this: CHCl3. This is chloroform. Here we can remove 3 molecules of HCl. We can remove what? 3 molecules of HCl. Product obtained, it is Rn, it is C, RNC plus 3 HCl, RNC plus 3 HCl. This is R means alkyl, Cn means isocyanide. Sorry, NC means isocyanide, Cn means cyanide. Cn, it is cyanide. This is NC, isocyanide. RNC, alkyl isocyanide, also called as what? It is also named as carbylamine. Also named as what? Carbylamine. In the next step, see these 3 molecules of HCl. HCl means it is an acid, hydrochloric acid. It will react with 3 molecules of a base, potassium hydroxide, alcoholic potassium hydroxide. Acid base reaction takes place. This is acid, this is base, will get hot. Acid base reaction always results in salt and water, formation of salt and water. So this is acid, so it should liberate H plus, KOH, it is a base, it should liberate OH minus. H plus combines with OH minus forming water, 3 molecules of water, because we have taken 3 molecules of acid and 3 molecules of a base. Salt obtained, that is KCl, 3 molecules of KCl, 3 molecules of KCl. So 3 HCl plus 3 KOH gives what? 3 KCl plus 3 H2O, 3 H2O. Okay. So now I can add these 2 steps. HCl cancels out. Remaining species I can write it here. It is RNH2, CHCl3, this one. Next it is 3 KOH, alcoholic, giving hot. RNC, alkyl isocyanide, plus it is 3 KCl plus 3 H2O. RNC 3 KCl plus what? 3 H2O. Alkyl isocyanide along with potassium chloride and 3 molecules of water. In the exam, if they ask explain carbylamine reaction, what you have to write is when aliphatic or aromatic primary amine, when it is heated with a mixture of chloroform and alcoholic potassium hydroxide, alkyl isocyanides having foul smell are obtained. This reaction it is called as what? Carbylamine reaction, or it is isocyanate test. And equation you have to write only last equation. This is sufficient. So this equation you have to write. No need to write the steps. So RNH2, CHCl3, 3 KOH. I will write it once again. So this is the equation you have to write for the exam. This is RNH2, chloroform, 3 molecules of potassium hydroxide. This mixture it is heated, delta, product obtained, it is RNC, alkyl isocyanide, byproducts are 3 KCl, 3 H2O, 3 KCl along with 3 molecules of H2O. Now this is the equation you have to write for the exam. For example, methylamine, when it is heated with chloroformane, alcoholic potassium hydroxide. Methylamine heated with chloroformane alcoholic potassium hydroxide. Product obtained, it is CH3NC, 3KCl, 3H2O, 3KCl plus 3H2O. This is methyl, CH3 means methyl, NC isocyanide. So name of this compound is methyl isocyanide. Even we can take aromatic amine also, aniline, benzene ring containing NH2 group, aniline, heated with what? With chloroformane alcoholic potassium hydroxide. In the place of R, we are having C6H5, so it is C6H5NC. Byproducts are same, 3KCl, 3H2O. So C6H5NC means C6H5, it is phenyl. When it is considered as a substituent group, it is named as phenyl. It is phenyl isocyanide, phenyl isocyanide or carbylamine having unpleasant smell or foul smell, or it is intolerable smell. Phenyl isocyanide, it is the product obtained when aniline reacts with the mixture of chloroformane alcoholic potassium hydroxide. Methyl isocyanide, it is the product obtained when methylamine reacts with chloroformane alcoholic potassium hydroxide. Very important reaction, you have to study this reaction. Next, third one, reaction with nitrous acid. Reaction with nitrous acid. Formula of nitrous acid, it is HNO2. HNO2 means nitrous acid. See, nitrous acid, it is an unstable compound. Nitrous acid, it is an unstable compound. It cannot be stored in the laboratory for a longer time. Suppose if we want nitrous acid for any chemical reaction, in that case we will prepare this nitrous acid at that moment. Since it is not available, or since it is unstable, we can't store it in the lab. So suppose if we want this nitrous acid for any given chemical reaction, then we have to prepare this nitrous acid at that particular moment. How nitrous acid is prepared? See, nitrous acid, it is obtained by treating sodium nitrite. Nitrous acid, it is obtained by treating sodium nitrite with HCl. With HCl. So when sodium nitrite, when it is made to react with HCl, I will get NaCl, sodium chloride, along with HNO2, nitrous acid. So HNO2, it is prepared by treating sodium nitrite with HCl. Let us explain this reaction of amines with nitrous acid. See, aliphatic amine, that is RNH2, aliphatic primary amine, it reacts with nitrous acid, this one. So nitrous acid can be written as, it is ON OH. Why do we write it like this? See, O, double bond, it is N, single bond O, single bond H. This is structure of nitrous acid. Structure of what? Nitrous acid. So, we can write it like this. HNO2 can be written as ONOH. ONOH. Okay, nitrous acid. It is prepared in acidic medium, correct? So, plus HCl, plus what? Plus HCl. During the reaction, water molecules are removed. Totally 2 molecules of water, 2 molecules of water. So, product obtained, it is R, NN, it is N2, N2, this is Cl, Cl minus N2 plus, it is R, N2Cl plus 2 molecules of water, plus what? Plus 2 molecules of water. See, compounds containing N2 group, compounds containing N2 group, they are called as diazonium compound. Azo means nitrogen, diazo means 2 nitrogen atoms. Diazo means 2 nitrogen atom. So, compounds containing N2 group, they are named as diazonium compound. So, this is diazonium compound. What is this? Diazonium compound. Name of this diazonium compound, it is alkyl, because there is an alkyl group, alkyl diazonium salt, or it is alkyl diazonium chloride, alkyl diazonium salt or alkyl diazonium chloride. Now, this alkyl diazonium salt, it is unstable. It is what? It is unstable. It undergoes hydrolysis. Hydrolysis means decomposing an organic compound in the presence of what? In the presence of water, H2O. So, in an aqueous solution, this compound will undergo hydrolysis, forming, what is this? This is H plus OH minus. So, we will get HCl. Nitrogen gas will be liberated, N2. Along with that, we will get ROH. ROH means it is alcohol. So, aliphatic primary amine reacts with nitrous acid, producing alkyl diazonium salt. Alkyl diazonium salts are unstable, readily undergo hydrolysis, or they will decompose in the aqueous medium, forming alcohol with the liberation of what? Nitrogen gas. Nitrogen gas. No need to write all these things for the exam. This much is sufficient. It is RNH2, NaNO2 plus HCl. Product, it is R, N2Cl, N2 plus Cl minus, will undergo hydrolysis, giving alcohol, nitrogen gas plus what? Plus HCl. This is alcohol. This is in the case of aliphatic primary amine. In the same way, aromatic amines also, they also react with what? They also react with nitrous acid, forming diazonium salts. Let us take aniline. First step, it is same, nitrous acid, it is obtained by treating NaNO2 with what? With HCl, producing NaCl and nitrous acid. Aniline, this is aniline, reacts with nitrous acid, plus HCl, because this compound, it is produced by the reaction of HCl plus HCl at a low temperature, that is 273 to 278 Kelvin, or 0 degree to 5 degree Celsius. 0 degree to 5 degree Celsius. Removal of water molecule takes place. Removal of what? Removal of water molecule. Totally 2 molecules of water. So, here I can write the product. it is benzene ring NN, that is N2Cl, N2Cl, N2 plus Cl minus, N2 plus Cl minus. So, plus what? Plus 2 H2O. Name of this compound benzene diazonium. N2 means diazonium chloride. Benzene diazonium chloride is obtained. Remember, diazonium compounds are very important class of organic compounds, and these diazonium compounds are used as the starting material for the synthesis of other organic compounds. So, most of the organic compounds, they are obtained from diazonium salts or diazonium compounds. So, this is benzene diazonium chloride, which is obtained by the reaction of aromatic amine with nitrous acid at a temperature of 273 to 278 Kelvin. Product, it is called as diazonium salt, or it is benzene diazonium chloride. Benzene diazonium chloride. Last reaction with aryl sulfonyl chloride. Reaction of amines with aryl sulfonyl chloride. It is also called as, aryl means benzene ring, benzene sulfonyl chloride. Benzene sulfonyl chloride. This reaction, it is named as Hinsberg's test. This reaction, it is named as what? Hinsberg's test, and reagent used in this reaction, it is called as Hinsberg's reagent. Hinsberg's reagent, it is just like Lucas test. See, Lucas test, it is the test used to distinguish primary, secondary, tertiary alcohols. Hinsberg's test, it is a test used to distinguish primary, secondary, tertiary amines. Primary, secondary, tertiary amines. Reagent used in Hinsberg's test, that reagent, it is called as Hinsberg's reagent. That reagent, it is called as what? Hinsberg's reagent. Hinsberg's reagent means benzene sulfonyl chloride. So, benzene sulfonyl chloride, it is named as Hinsberg's reagent, and this reagent, it is used in Hinsberg's test. Purpose of conducting Hinsberg's test, to distinguish primary, secondary, tertiary amines. See, Hinsberg's test, it is answered only by primary and secondary amines. This test, it is seen only in the case of primary amines and secondary amines. This reaction, it is not seen in the case of tertiary amines. Not seen in the case of what? Tertiary amines, because tertiary amine does not contain any hydrogen upon nitrogen atom. Does not contain any hydrogen upon nitrogen atom. So, it cannot react with Hinsberg's reagent. Cannot react with Hinsberg's reagent. Let us write the equations for primary and secondary. Tertiary does not react. I will take primary amine, ethylamine. I will write it like this. This is primary amine. It is made to react with benzene sulfonyl chloride. Structure of benzene sulfonyl chloride. I will write it in reverse manner. Chloride. Then I have to write sulfonyl group. S double bond O, S double bond O. Then it is benzene ring. Benzene ring. During the reaction, HCl, it is eliminated. Product obtained, it is C2H5NH, C2H5NH, then it is S double bond O, double bond O. This group, it is named as sulfonyl group. then it is benzene ring plus HCl plus HCl. Name of this compound, again there is what? There is a substituent group upon nitrogen, so it can be written as it is N-ethyl. What is this? N-ethyl. Name of this compound, instead of C, benzene ring containing CONH2. CONH2 means amide, correct? It is what? It is an amide. Benzene containing CONH2, it is called as what? Benzamide. Called as what? Benzamide. So in the place of C double bond O, we are having what? S double bond O, S double bond O. So compound can be named as, instead of benzamide, it can be named as benzene sulfonamide. It is named as what? Benzene sulfonamide. Benzene sulfonamide. So product obtained in the case of primary amine, that is N-ethyl benzene sulfonamide, and this compound, it is acidic. This compound, it is what? It is acidic, readily dissolves in alkali, or it is soluble in alkali. Alkali means base. Soluble in alkali. Now why this compound is acidic? What do you mean by acidic character? When a compound is called as acidic compound, if a compound, if it liberates H+, then that particular compound, it is considered as acidic compound. It is considered as what? Acidic compound. Now N-ethyl benzene sulfonamide, this is acidic because it liberates H+ ion. Liberates what? H+ ion. See, we can see hydrogen here upon nitrogen. Hydrogen upon what? Upon nitrogen. See, this hydrogen can be easily removed in the form of H+. In the form of what? H+, because nitrogen, it is directly bonded to electron withdrawing group, that is sulfonyl group. Nitrogen, it is directly bonded to electron withdrawing group, sulfonyl group. So electrons will be displaced towards sulfur. As a result, hydrogen becomes electron deficient, or it carries partial positive charge, correct? So bond becomes weaker. Nitrogen hydrogen bond becomes weaker, and this hydrogen can be removed in the form of H+. So compound becomes acidic. I will repeat it once again. N-ethyl benzene sulfonamide contains a hydrogen atom upon what? It is present upon nitrogen, and this hydrogen can be removed in the form of H+, because nitrogen hydrogen bond, it is weaker due to the presence of electron withdrawing group, electron withdrawing sulfonyl group. As a result, bond becomes weaker, hydrogen can be easily removed in the form of H+, compound becomes acidic. Since this compound, it is acidic, when we add a base, or when we add an alkali, this compound dissolves. Acidic compound always dissolves in a basic solution. So this compound, it is acidic. On adding a base, this compound dissolves. So given compound, if it dissolves in alkali, then it is clear that given amine, it is what? It is a primary amine. Let us take secondary amine. Example for secondary amine, diethylamine. This is diethylamine, secondary amine, reacts with benzene sulfonyl chloride, that is Cl, S double bond O, then it is benzene ring. This is benzene sulfonyl chloride removal of HCl, product obtained, it is C2H5, then it is N, again C2H5, next we have S double bond O, benzene ring plus HCl, plus what? Plus HCl. Now in this compound we can see two substituent groups. These are the two substituent groups. Both are ethyl groups. Both are what? Ethyl groups, and both the ethyl groups, they are present upon nitrogen. So it is named as N, N. It is named as what? N, N, because there are two alkyl groups, N, N diethyl, N, N diethyl benzene sulfonamide. N, N diethyl benzene sulfonamide, and this compound does not dissolve. This compound does not dissolve, or it is insoluble in an alkali solution, so does not dissolve on adding a base, whereas compound obtained in the case of primary amine readily dissolves in alkali. Compound obtained in the case of secondary amine remains as it is insoluble in alkali. Why it does not dissolve in alkali? Because this compound, it is not acidic. This compound, it is not acidic. Solubility can be seen only if it is acidic, correct? Or only if it is soluble. Soluble means compound has to be acidic. So this compound, it is not acidic because it does not contain any hydrogen here. Upon nitrogen, we can't see any hydrogen. So compound, it is not acidic. So since compound, it is not acidic, it cannot dissolve on adding what? On adding a base. So if a given formed compound does not dissolve in alkali, then given amine, it is what? It is secondary amine. So product obtained during this reaction, if it dissolves, then it is primary amine. Dissolves in alkali, that is primary amine. Formed product, if it does not dissolve in alkali during the reaction, then it is considered as secondary amine. What about tertiary amine? Tertiary amines do not respond to this reaction, or they do not answer Hinsberg's test. Because they does not contain any hydrogen upon nitrogen atom. So by this way we can distinguish primary, secondary, tertiary amine. So primary amine reacts with Hinsberg's reagent. See, for 1 mark they can ask, what is Hinsberg's reagent? Benzene sulfonyl chloride, it is called as Hinsberg's reagent. Primary amine reacts with Hinsberg's reagent forming N-ethyl benzene sulfonamide. It is acidic, dissolves in alkali. Secondary amine reacts with Hinsberg's reagent forming N, diethyl benzene sulfonamide. It is insoluble in an alkali, does not dissolve in alkali because this compound, it is not acidic. Tertiary amine does not answer this test due to the absence of hydrogen atom upon nitrogen. So totally 4 reactions we have studied in today's class. One is acylation, carbylamine reaction with nitrous acid, and last one, Hinsberg's test. This is also very important, Hinsberg's test, which is used to distinguish primary, secondary, tertiary amines. Thank you.